We want more examples on taking off substructure works. This was a statement made by most students in our previous video, which I posted about taking off substructure works. There are those who felt that we were doing so complicated examples, yet we have not done enough simple examples. So this video is actually for you, so that you can go step by step. The easiest point to start, we said you can start with a regular rectangle. If you use a regular rectangular plan, then you can go to the one with one recess, you can go with two recesses, then you can go to plans where we have even a center wall, then you can go to plans where the walls on the outside are different to the ones in the inside. You can graduate to the one that has columns. So see, small. You start small, you go growing, so that you can be able to understand every concept. So we are doing quite a number of examples. We are doing so many examples. Actually, the ones that we are doing now, I have got these questions from KNEC papers. For all those who are preparing for your KNEC exams, this is the best point to start, because once you revise using KNEC papers, you'll be ready for the KNEC exam. And for all those who are not doing KNEC exams, KNEC is a very accredited exam in our country. It is among those exams that are actually recognized internationally. So the standards that we are following with the international standards. So let's get started for today's video. We are taking off the substructure works. It's a simple plan. It has recesses. Actually, it has two corner recesses. Then you can see from the plan, we have the section AA, and it's here, the section AA, whereby it's just a simple section because it's a strip footing whose width is 600 millimeters, and the thickness of the concrete at the bottom is 200. Then the height to the ground level is 1950. Then the height to the top of the oversight concrete is 200. So we said whenever you're given a plan and a section and you're asked to take off, the first thing you do is to study your plan and your section. So once you can see, like for example in the plan, the dimensions you're given for the internal dimensions for the walls, then you're given the thicknesses of the walls. You can see they are in to in, then the dimensions of the wall. Then on the wind side, they're also in to in, then the dimensions of the walls. So whenever you want, for example, to find the total in the length and the total in the width, you just add the dimensions. Okay, then we can go to the section. Also, we need to study it. We have the 100 millimeters oversight concrete, it's here. Then we have the BRC in the concrete. Then we have the 500 gauge D.P.M. We have the 315 millimeters hardcore, and there's 50 millimeters Murram Blinding on the hardcore. Then the wall here is 200 thick for stone wall, and the concrete at the bottom is 1:3:6 foundation concrete. The notes, the site is bushy, so you need to clear the site, remove the vegetable soil, which is 150 millimeters. Then we have the rock, which exists 1500 millimeters below the ground. Alright, now after studying the plan, you need now to go to taking off. Alright, so in taking off all the works, you need to follow the procedure. First, you write down the procedure so that you can be referring to it as you take off. You can be able to refer there, which is the next item. Alright, so you start with site clearance. Then you go to excavating the oversight, that is the vegetable soil. Then after that, actually you should excavate to reduce level. You should just calculate if you need to reduce the level again to where you lay the hardcore. Then after that, you shall excavate foundation trenches. Then you lay the concrete foundation. Then you shall do the foundation walling, lay the hardcore inside the walls, do the Murram Blinding above the hardcore, then D.P.M and anti-termite treatment, you do it on top of the Murram, then you do the formwork, and finally the floor bed. So let's go to site clearance. We said that we clear the site and also include the foundation spread. Yes, the foundation spread, you learn from it. We get it from the foundation strip. The foundation strip, if you deduct the wall, then you divide by 2, you'll be able to know what is the length of this spread. The red the red line is the spread on the outside, spread on the inside. The inside spread doesn't affect the dimensions of the walls, because up to the edge of the wall, you see, from the section, this wall, outside wall, the one I am shading in red. On the plan, it is this wall here. So up to there, the inside spread is already catered for, but we have this spread outside, and it is this spread on the section which is on the outside. So how do we calculate for that spread? We take 600, we deduct 200 for the wall, then we divide by 2, we get 200 on each side. So projection, as you can see, we multiply by 2 for both sides. For the length side, length we shall add 400. For the width we shall add 400. This one was the dimensions of the internal walls. For the length and width, then you have to add the walls. Alright, then we say that whenever we are doing a rectangle with corner recesses, we will always assume that we are taking off a rectangle, then we shall deduct the voids. For example, in this plan, considering, so when we are clearing the sides and we are adding the foundation spread on the outside, the rectangle will be like this. We are adding the projection on the outside. We shall take it as a straight rectangle. Alright, just follow the lines. If you haven't subscribed, kindly subscribe, and also if you like this video, give it a thumbs up as I finish to draw that one. So the rectangle will be like that. Now the voids that we shall deduct, they are like this. We shall deduct this one, that is one void, and you remember this is the wall, so this wall shall have a spread, it shall have its spread there. So the void, it will be up to down here, then up to there, because those walls need to have a spread. Then there's this other one, the other one will have its spread there up to there. Alright, so there will be no this one. Alright, so you can see the voids where there are. Alright, so if I am to shade it using my yellow pen, this is one of the voids here, because we need to allow the projection for the walls. Then this one is another void from the rectangle with a projection. Okay, now once you identify the voids, it will be much easier now to take off. So we shall measure the rectangle as a whole. So the dimensions of this rectangle, they shall be, you take 200 plus 8,000 plus 200 plus 4,000 plus 200 plus 4,000 plus 200. Then you add the projection this side 200, the projection this side 200. For the wind, projection this side 200, then 200 for the wall, 2,200, 2,200, 2,200, then 200 for the other side. Good. Now I hope everyone can see where 17.2 and 7.2 comes from. So in that area, we shall clear the site of all bushes, grass, and undergrowths, and burn away all arising. Then on the same area, we shall excavate away 150 millimeters deep vegetable soil. Remember, we had been told in the notes here that the topsoil is 150 millimeters. To remove vegetable soil and deposit it in soil heaps on site, average 100 millimeters distance from the site. And also the same area, we shall reduce the level. How do we know how much we shall reduce the level? We shall come and add all these layers here. For the concrete, 100. For D.P.M, it has no thickness. Hardcore is 315. Then Murram 50. So 315 plus 50, 365 plus 100, 465. For 65 up to the top of the slab, up to the ground level is 200. For 65 minus 200, it's 265. Then we remove the vegetable soil for 150. So 265 minus 150 shall remain with 115. So we need to excavate another 115 millimeters deep. And this one, we call it excavating reduced level, commencing from stripped level, from where we stripped away the vegetable soil. We go deeper, 115 millimeters, and cut away from the side. We now need to deduct the void. The void, as we marked on the previous diagram, the walls for the projection for site clearance are heading this way, and here around the void, I'm just drawing the one around the void, assuming that this is a straight line and its allowance is 200 for the foundation spread. The void, you can see that here this wall has to have a spread of 200. The other one we have to allow 200, and this one. So we can see where the void comes in. Now for this void, which is up to here, actually it's up to here, so that we can do a straight line. What is the dimensions of that void? From here to here it's 200. From here, this wall thickness is 200. Then this one is 4000 minus 200 here. So we shall start 200 plus 200, 400. 400 plus 4000, 4400, minus 200 for here. For this foundation spread over here, it's a foundation spread, you remember. So for 4400 minus 200, 4200. So this one is 4200. Then for the width, the wall is 200. Then the width here is up to the end is 2000. But here you can see we have the spread of 200. 2000 minus 200 is 1800. 1800 plus 200 for the wall, 2000. 2000 plus 200 for the outside is 2200. Then now we shall go to this other void. Its dimensions for the length, first we shall start with this 200 on the outside, then this 200 for the wall, then we add 2000 here. 2000 plus 400 is 2400, plus 200, 2600. 2600 plus 2000, it shall give us 4600. 4600, then we deduct this 200, 4400, which is this one here. The width, we have 4000 plus 200, 4200, plus the projection 200, 4400. Then we deduct this 200. We deduct this 200 from 4000 because this one was a total of 4000. We deduct this 200, so it shall be 4000 minus 200, that's 800, plus 200, 4000 plus 200, 4200. So we shall say deduct detail the last three items on void. Alright, so we shall go to excavating the trenches. Now we need to know the center line of the trench so that we can multiply by the depth of the trench to know the volume of the soil that shall be excavated. So the center line of the trench, we say that we shall take the external dimensions of the spread. This spread, there's someone who was asking a question. This spread, this one that I have shaded in yellow, is on the outside. So once we come to the diagram, we shall add the spread all around the building, 200. I hope that is a bit clear. We shall add it all around the building. So all around we are supposed to add 200 on each side. Okay, so all around we shall have the spread. Yes. So for the length that we had of 16,400, we shall add 200 on the each side. We get 16,800 to get the external from here, because we shall take the external dimensions. Then we shall you see this is the trench, so the external dimensions of the spread is the edge of the spread. So 16,800. Then for the width, adding the spread is 6,800. So the perimeter considering the spread is 47,200. Then we shall deduct, here it's where you note the difference, number of corners times the width of the trench. If you have not got that concept of center line, kindly go to the video on center lines. You need to understand this concept, because a lot of students get confused here. You have to take the external dimensions of the thickness that you want. Now our thickness here is the thickness of the trench, which is 600. So we shall take number of corners. Number of corners we take by number of external corners minus number of internal corners. Let's count the external corners. This one is 1, 2, 3, 4, 5, 6 external corners. Then we shall deduct 2 internal corners. 2 internal corners, 1 and 2. 6 minus 2, 4. So that's why we have 4 here. 4 times the thickness of the trench, which is 600, we get 2400. So this one, 47,200, will less 2400, we shall get 44,800. That is the center line of the trench. And that one shall also be the center line of the walls, because the walls are at the center of the trench. So we shall not need to calculate another center line of walls, because the walls are 200 millimeters and they are at the center of the trench, which is 600. So the center line of the trench at the same point, it shall be the center line of the walls. Alright, so this one was the concept of finding the reduced level. If you did not get it, you can just check it out here. You take all these layers, the oversight, the hard coal, the Murram, you add them, then you deduct the height above the ground, then you deduct the depth of the vegetable soil, so that you can know how much you should reduce the level by. Okay, so let's go to the depth of the trench now. You can see this 1950 here. Let me use a red pen. 1950, it's from the ground level to the concrete of the strip foundation. Then you add 200 for the concrete. This one is the total depth below the ground level. We shall less 265. This one is for the reduced level, which was 115, plus the vegetable soil, which was 150. So if we deduct this one, we shall see that we are remaining at 1885 millimeters to excavate from the reduced level. Then we excavate in stages of 1500. So the first stage, it shall have 1500 millimeters deep. Then on this other stage, we shall have 385 millimeters deep. Now the rock, we are told that it starts 1500 millimeters from the ground. What is the depth that we're excavating from the ground? It is this 2150. So if the total depth of excavation is 2150 and the rock starts 1500 millimeters from the ground, so the total depth of the rock that we shall excavate is 650 millimeters. Okay, so now the volume of soil that we shall excavate, we shall take the center line of the trench times the width of the trench times the depth of the trench, first stage. Then center line of the trench times the width of the trench, then the second stage, depth of the second stage. The first stage, you shall write excavate foundation trenches commencing at reduced level, not exceeding 1.5 meters deep, and that soil shall be added to the heap called R.F.R, the heap of soil. Then the other one shall be excavate foundation trenches commencing from 1.5 meters deep and not exceeding 3 meters deep. That's why you add it to R.F.R. Then for the rock, there is extra over excavation on rock. Now this one, we shall take the same center line, then we multiply by the width of the trench, then the depth of the rock that shall be excavated. Alright, okay, so after excavating the trench, we need to do planking and strutting to the strands of the excavation trenches, and also to keep the trenches away from water, dewatering the sites. This one, in our system, we write item. This one, we shall allocate a provisional sum in the bill of quantity using the SMM. Alright, then we shall go to mass concrete in the foundation trenches. This mass concrete is the one that here I will shade with red. It's this concrete here. How do we take it off? It is 200 millimeters thick. So for the foundation concrete, we usually measure it in volume. Alright, so we shall take the center line of the wall of the trench, then we shall multiply by the width of the with the width of the trench, then we shall multiply by the thickness of the foundation concrete. Then mass concrete ratio 1:3:6 in foundation trench, and deduct from R.F.R. You see, this concrete shall replace the soil in the trench, so that volume of soil equal to the volume of concrete shall be deducted from R.F.R, the soil that was to be used in refilling, and to be added to that heap of soil called cut away, so that it can be disposed away from the site. So you add it to cut away. Alright, so we need to build the stone walling. The height of the foundation wall, it's from here where I'm shading up to the concrete. What is that height? That height up to the ground level, it's 1950. Then you add 200 to get to the total from up here, from the oversight concrete to down. 1950 plus 200. Once you deduct for the oversight concrete, which is here, you remain with the height of the wall. So 1950 plus 200, 2150. Then you deduct 100 for the oversight concrete. You remain with 2050 millimeters. So if we take off wall in area, so the center line times the height of the wall, then you just write 200 millimeters thick stone walling in cement slab ratio 1:3 mortar joints. We shall now go to height of foundation walling. We want to know what volume of soil have been replaced by the wall. So we'll calculate the volume of the wall up to the reduced level. So we shall find the height of the wall up to the reduced level. The total height of the wall up to over the oversight concrete was 2150. Then we deducted for the oversight concrete. Then we deduct for the blinding and for the hardcore, so that we can go back to the reduced level. So the height of the wall from the strip concrete to the reduced level is 465. No, the 465 is the total of these layers. So the height shall be 2150 minus 465. You get 1685. So the volume of that wall shall be the center line times the width of the wall, which is 200 millimeters thick, times that height, which is 1.69. You deduct this volume of soil from R.F.R and add it to cut away, so that you can dispose it away from the site. Now we shall go to the hardcore. The hardcore is usually laid inside the walls. So here we shall take the walls. You see the walls are here. So the hardcore was laid using our rectangle that we use up to here. You know, we take it as a full rectangle. We shall take the dimensions of this rectangle here. Then we shall deduct the voids. You know, we don't lay hardcore on top of the walls, so these walls will not be included in they will be in the void part. Yeah, we shall take the whole rectangle, then we deduct that one. The whole rectangle, we shall take 8000 plus 200 plus 4000 plus 200 plus 4000 plus 200. We get 16.4. Then for the width, we shall take 2000 plus 200 plus 2000 plus 200 plus 2000. We get the width. The depth of the hardcore is 0.32. Then we shall deduct for detail. Now detail for on void. The void now, the dimensions from here up to here. What is the dimensions? From here we shall take 200. All right, 200 plus 4000 plus, it's up to there, because this other one will form a rectangle on its own. 2000 plus 4000 is 4.2. Then the other one for the width, it's from here to here, 2000 and 200, 2.2. The depth is 0.32. The other void, the length, which is the longer part, we shall take 200 for the wall, 2000 plus 200 for the other wall, plus 2000, we shall get 2000 plus 200, 22, plus 2000, 4.2, plus 200, 4.4. 4.4, then the width now, we have 4000 and 200, 4.2. all right. Then the depth is 0.2, so you shall deduct ditto on void. Okay, all right. So we shall now lay the Murram on top of the hard core. Then we shall treat the surface with insecticides. So the dimensions for the Murram Blinding we shall take just like for the hard core. So we shall take the internal dimensions of the length and internal dimensions of the width up to here. Then we shall deduct the voids. The voids are up to there. You know, the Murram is usually laid on top of the hardcore. Alright, up to there. The same dimensions, just like we measured in the previous one. So we go to the polythene together with the vibrated reinforced concrete on the oversight concrete. That one we shall include the walls. It's just like for the hardcore, but now we shall include the external walls because it will be from here. You know, the damp-proof membrane is usually done even on the walls up to here. Then we shall take our external rectangle up to there, then up to here and up to here. So we shall take that rectangle. Then when we are deducting the voids, we shall not include the walls this time on the voids because they shall be covered where we are doing concreting. We are doing concreting on the walls and also the D.P.M. So I hope now you can see. So we shall check this length, the external dimensions of the length, this one, the external dimensions of the width, this one. Then for the voids, we shall check this dimension up to here, this one. Then we shall check the other dimension for the width up to there. Okay, for the bigger one, we shall not include the walls, this one, and we shall here 4.2. all right. So now we shall go to formwork. Our last time before we do the centerline of reinstatement, whereby we shall just take this length. You see this width, the length of this width is also equal to this one and this one and this one. That's why we are just multiplying by 2 the width. The length, this length which is long here, is equal to this one plus this one plus this one. So the length will not change. You multiply by 2. So for soil press formwork to vertical edges of oversight concrete, we shall finish with centerline of reinstatement, whereby we take the centerline of the spread here, because the spread is up to here, 200. Now this one we shall come at the center of this spread. So you need to find the external dimensions of the spread. Remember, external dimensions of the spread. Then we deduct the number of corners times the thickness of that spread alone. So what guides you is this one. If we are taking number of corners times the thickness outside the walls, so what will be the length of the external dimensions outside the spread? Because this 200, if I'm to highlight, this one is because there are those questions that are coming. If I'm to highlight, we are finding the center line of this part that I've shaded in red. So we shall take the external dimensions, which shall be along this line that I'm marking here. You give an allowance of 200 to the external dimensions of the walls all around the building, because we want to find this center line at the center of the spread that is outside. So, and also you should note that the center line of reinstatement, we usually reinstate the soil from the reduced level up to the topsoil. So we shall take the center line of reinstatement, which is taken by the center line of the walls. We add the spread on both sides. We get for the length is 17,200, for the width 7,200. Then we shall deduct number of corners times the thickness of the wall, the thickness of the spread, which is being reinstated. So we deduct 800. We get 3,800. So it shall be 30.8 which is the centerline of reinstatement. It's not the same as the centerline of the trench or the centerline of the wall. Then we multiply by the width of the reinstatement. Then we multiply by the depth of the reinstatement from the reduced level to the topsoil. So you shall say you shall deduct this load from cut away. It was to be taken away from the site after we clear the site of the vegetable soil. We add it to refill and ramp because we shall use this soil again. So that brings us to the end of the video. If you have liked this video, kindly give it a thumbs up. If you haven't subscribed to our channel, kindly, this is the only way that you can help us, as you can support our channel so that you can continue to make content for you. Kindly share our videos to your course mates, bring them on board so that you can continue, we can feel motivated to continue making content for you. Thank you for all your compliments in the comment section. Thank you for all your questions. Actually, we are doing our best to answer them. For those videos you've asked for and you have never done them, we are preparing for them. Kindly be patient, and every week we shall be doing a new video, even as we give more examples for all the other videos that we have already done. So thanks for your support this far, and for keeping tuned to our channel. Continue watching, continue bringing more to our channel, and we shall continue to make content for you. Thank you so much and have a good day.